Welcome. In this lecture, I want to talk about how we actually add elements of Z mod MZ. So just to remind you, and this is notation for exactly the same thing there. So when we have ZM, right, this is, as a set, this is, we're going to have, right, so we have like 0 bar, which is the equivalence class of 0, because we're looking mod M, right? 1 bar, which is the equivalence class of 1. And we keep on going up, and we need to go precisely to m minus 1 bar, which is the equivalence class of m minus 1. Okay? So this is what this is. So how would we add two elements of here? So equivalence classes are going to be added exactly as one might guess. So equivalence classes are added. Ooh, it's not quite. It's not how you spell exactly. It's not exactly how you spell exactly. Exactly as one might guess. Okay. So how would I add the equivalence classes of, and I'm going to do this like, yeah, I'm going to do it like this. So if I have the equivalence class of, I want to put I'm going to just do the bar like this. So equivalence class of X plus the equivalence class of Y is going to equal, and this is actually going to equal the equivalence class of X plus Y. Okay, so you can really add within. So there's something to say in terms of that being well defined. This has lots of elements. This has lots of elements. I wrote some representative, but how do I know that adding those would be the same as adding two other representatives in the same equivalence class? So for example, in Z4, so example, if I'm looking in particular in Z4, right, and I want to add the equivalence class, so I'm going to do of 2, the equivalence class of 2 plus the equivalence class of 3. I'm liking my notations. I lost my color coding, but what are we going to get? So this is going to be, well, okay, this is the equivalence class of 5, because that's what I get when I add 2 plus 3. But we really usually wouldn't write that, right? Because Z4 is going to equal, usually we like to write things as 0, 1, 2 bar, 3 bar. Usually we like to get them down to their one that's the smallest non-negative representative. So usually we would prefer to write this as 1 bar, right? And why are these the same thing, right? These are the same since if I take 5 minus 1, right, this is equal to 4. So that tells me that, well, 4 divides 4, so 4 divides 5 minus 1, which is going to tell me that 5 is congruent to 1 mod. So 5 is congruent to 1 mod 4. Kind of just keep the same colors there. Okay, so using this this way, you can add it, but usually you want to bring it down to the smallest representative. So let's look at an example. So addition in Z4, right, can be represented by the table. Where I'm going to have I'm just going to, let's just do the table and wait. Okay. So how many lines am I going to want to do it this way, this way, this way? Okay. I guess I could have also just thought that through. So. Okay, that's too unequal. I could have thought this through and done a better job. Sorry that that's not as nice as one might hope. Okay. Interesting. I think I do a slightly better job when I just start going, knowing how many I'm going to need. Okay. So this is for addition. And then up here, we're going to have, we start with 0 bar, and 1 bar, and 2 bar, and 3 bar, and 0 bar, 1 bar, 2 bar, 3 bar. Okay, so some of the first ones, if I add 0 to anything, I get the same thing because I'm adding 0 within these, so I get the same thing. So these ones are not as bad. And I can do the same thing here. I'm adding 0 to each of these. So 0 plus 1 is 1, so I get 1 bar. 0 plus 2 is 2, so I get 2 bar. 0 plus 3 is 3, so I get 3 bar. Okay. And then I'm going to keep on going. So 1 plus 1 is 2, so I get 2 bar. 1 plus 2 is 3, so I get 3 bar. 3 plus 1 is 4, so I decide to go back to 0 bar, right? So this one might be a little trickier, so let's bring in another color. So how did I figure out this one here? I went 1 bar plus 3 bar equals 1 plus 3 bar equals 4 bar. But 4 is congruent to 0, mod 4, so this is equal to 0 bar, right? Because 4 and 0 are congruent, mod 4, okay? And then the next one, so we go 2 plus 1 is going to be 3 bar. 2 plus 2 is going to be 0 bar. Again, we have a similar kind of circumstance where we have, so for this one here, right, what do we do? So we go 2 bar plus 2 bar equals 2 plus 2 bar equals 4 bar equals 0 bar. Why are these equal? And these are equal because what's going on there, which is that 4 is congruent to 0 mod 4. So that's how we knew that. Okay. Now, so we can do a similar thing. So 2 plus 3, so that should be 5, but 5 is congruent to 1. Okay. So that's one of the tricky ones. Actually, let's even. I'm on a roll with making these. The ones that are a little trickier, I'm just doing off to the side, right? So this is 2 bar plus 3 bar equals 2 plus 3 bar equals 5 bar equals 1 bar. Why is that? This is because these are congruent. So 5 is congruent to 1 mod 4. Okay. So now we have 3 plus 1. So we've kind of seen this one before more than once. 3 plus 2 should be 5 bar, but again, so this is 1 bar. And then what about 3 plus 3? We'll highlight how to do that one. So 3 plus 3 bar, so 3 bar plus 3 bar equals 3 plus 3 bar is going to equal 6 bar. And then we're looking at congruence mod 4, so I want to subtract off 4 and then get that down to 2 bar, right? Right, these differ by 4, so they're congruent mod 4, and so I can use that in order to tell me that this one here should actually be 2 bar. Okay. So that's how you add them. You kind of add them under the bar, but you want to bring it back down to the representatives that are like non-negative and closest to 0. So I hope that made some sense, and I will see you in the next lecture.